Good morning, everyone, or good afternoon, depending on where you're watching from. So please let me know where you're watching from. Unfortunately, Alex is not feeling well today, so I'm doing it by myself. If you have questions, please post them in the chat. I'll try to answer them if I notice them, and also call out people. So share where you're watching from. And hope you had a great weekend. Mine was both great and not so great. So the not so great part was I had to do taxes, which is always a big pain for me. So I spent many hours organizing and sorting out tax papers and so on. But the great thing was we went to see Guardians of the Galaxy 3, which was really awesome. So if you have not seen it yet, please do so and have a wonderful movie experience. It was really, really great. And kind of sad that it's probably the last one. Today, we are in our Aura exploration. We look into something that I already looked into last Thursday in the long live stream, in the live coding live stream. But I thought it's also a really nice data set for introduction. So what we want to do today is actually look at Bluesky and Bluesky data. If you've not heard about the protocol and the initial reference app behind it, then you've probably sitting under a rock or something like that. There's a lot of hype around it. I recently saw that the waiting list is like now 1.6 million people or something like that. So, but actually Bluesky, the app, is not as important as the protocol behind it. So the protocol behind it is a distributed secure protocol for not just social media, but also other ways of sharing information. And you can see it a little bit as a competitor to the Fediverse activity feed activity pub protocol. So the AT protocol is basically based on individual distributed IDs. So everyone has a distributed ID. And then each service, so there are many distributed services, as you can see here in the federation part. Each distributed service has repositories of records, something like user information, posts, likes, and so on. And you basically sign your repo records with your key. And then people can, with your public key, can verify that this information came from you. And then basically information between those, or interoperability between those servers is handled by the AD protocol. And the AD protocol is based on HTTP and XRPC. There are already quite a number of clients for it. So I've seen from the Bluesky team, there's a Go client, but there are also Rust and Python clients out there, and TypeScript as well. The Discord for AD protocol developers has already 1,000 members. So it's pretty active. And then accessing the data to the outside world. So you have each individual repository, and then there are like larger things like an indexer for search and so on top of that. What's interesting is you have your own choice, or you will have your own choice of algorithm. So each feed and discovery section and so on. Right now in Bluesky, it's pretty basic, but in the future, the idea is that you as a user can define what your algorithm looks like, which is kind of nice. And there are a bunch of other things as well. So it basically works on this distributed identity where you on a domain name, so which can be your own, or an official one from one of the providers. You basically have a record which kind of verifies that this is your domain, right? And then this record is this distributed ID identifier here, and this is used then in all the interactions with your data while you post things, while you like things, while you reply to things, and so on. Right. So if you look at this in my case. So in my case, I added my domain here to, sorry, I added a text record to my domain here. And I added like the AdProto entry here. And in the entry, there's this DID prefix then, right? Which then also means that I can use the API to get access to the information from this key, which is then structured information. So if I do this curl request here, it basically gives me for this ID, which is my ID, it has like it's verified by this other key. There's some key rotation also built in that is used, and then basically this is also known as my own domain, basically, right? So you can have any number of also known as aliases as well. And right now there's only the Bluesky server, but in the future there will be more servers that will provide the PDFs, the data repositories. Right? So this is all very technical, and the domain, the protocol bits. If you want to read about them, you can find information in the here in the protocol docs. I'll just put them into chat. And if you want to learn more, there's, as I said, lots of code examples and also drivers and clients for the protocol as such. What I want to look into today is the following. There's this guy on Bluesky, Jazz, who has built a really cool Go-based infrastructure to capture data and build a social graph from it. And he posts basically the social graph as a live web app. Which actually is quite nice for us because we don't need to deal with the low-level protocol bits, but we can just use the data from his graph visualization to import it into Neo4j and then do our own analysis and visualization on top of that. Cool. So, and what he did is basically he wrote this Go infrastructure that basically listens to the feed, which is basically like Git commits. Can you imagine? Like you register to like commit events, and then whenever a commit event comes in, you can analyze that, extract who's talking to whom. He also adds it to a Postgres database. So if you want to look more into these details, check out my Thursday session that I did, where we dive deeper into the APIs. So I'll also paste this one into the chat as well. But what's interesting is the web app, right? So what he basically did is he put out this graph visualization, which is the social graph, which is basically computed while he's consuming these events from the fire hose, right? And so whenever two people interact with each other, there's an counter incremented on the relationship between them, and this social graph is then also stored as a binary file in his code. So he has basically an up-to-date social graph of all interactions of people here, right? And then you see recently he added clusters on top of that. So there's here like the Brazilian supercluster, the English language supercluster with interesting like the ALF. There was a really nice ALF interaction recently. Language, Japanese language, Turkish, Persian, Korean. There's a little Web3 cluster here. And then you can basically zoom in, and there's like lots of different people, right? So, and you can search for handles. So for instance, if I search for mine, then it shows me whom have I interacted with, basically. So from one of the developers, the CEO, to AOC, who's there as well, a bunch of other folks, Neil Gaiman, and Josh Long should be somewhere here as well, the Spring advocate, and a bunch of other folks as well, right? So and the nodes are visualized basically in size is kind of how many interactions they had in total, and the color is the different communities that they belong to, right? So you can search everyone. So for instance, if I search for AOC, and you see that she has a lot of interactions with a lot of people, so super active on Bluesky. Here, Alexandra Ocasio-Cortez, and other folks as well. Right? So you can find yourself as well if you're there. So for instance, if I look for Starbucksman, so Josh Long, so he has a few interactions as well here, right? So, and you can see second degrees neighbors of people as well, and so on. Right? In total, if you look at this again, let's see, it has, can I exclude, what's the reset somewhere? So in total, it has 20,000 users, 142,000 interactions as relationships, and 628,000 aggregate interactions as such, right? And what's actually nice about this is this uses data from, sorry, not this one here. This uses data basically from a JSON file, which you can use to load the data into Neo4j, right? So you have the clusters in here, but you also have things like nodes. You see here it's like each node has a key and then attributes like a label, which is kind of the name, size, area, color, XY coordinates for layout. So it's not doing the layout on your computer, it's just pre-computed layout as such, right? And then there's also an entry quotes edges. Let's see. Here, and each edge has a source and a target, and then also a bunch of attributes like weight and size and so on. So what I wanted to do is, first of all, import the data into Neo4j. And then second, we want to run some graph algorithms on that. So to run graph algorithms on Neo4j, we can't use our AuraDB free instance because it does not have the graph data science extension installed. But instead, we're going to use an AuraDS instance. I already created one, but I'll show you what it looks like if you create a new one, which is basically create instance. You could give it a name. So I just call this one test. I say our node, our graph is like 20,000 nodes, 200,000 relationships. I want to do centrality algorithms, community detection algorithms, and then I can calculate an estimate. And then that then tells me what size of instance, which is the smallest instance here for DS instance. And then I can just click on create instance and it will do the same, give me the password and the login credentials and then create the instance. But I did this already, so we don't have to wait for it to start. And then we can open Neo4j workspace here on this instance. So it's currently empty. And so if you look at the database here, it's an empty database, right? So what I want to do as such is to take this this JSON file that we've just seen and import it into this Neo4j instance. And what I've done is I created this GitHub gist, which has the code as well. So if you want to code along on your own Neo4j instance, feel free to do that. And we'll start with creating an unique constraint for the user key. And actually, we should also, I should change this. We should also create a unique constraint for the label as well. So the key is needed for connecting the edges in the JSON, but the actual primary key is the label because that's kind of the unique domain name that would be used when we interact otherwise with the data, right? So if I go to my workspace here, I can create this constraint. And then I also create one for label, user label, which should give me now the user node and label and something else, label and key here, right? So now we can look at the data. So initially we just look at the JSON and then we import it into Neo4j. So this is the JSON file that I just showed you with the nodes and the edges entry here. And we can use APOCLO-JSON, which is a user-defined procedure, which allows you to reach out to an API or load a file, a JSON file, and make this available to Cypher, our query language, as a structured data structure, right? So for instance, if you load something like that's a JSON object or so, you would get a Cypher map from it. And if it's an array of JSON objects, then you would get a list of Cypher maps from it. So it turns it also into not just a string, but a real Cypher data structure, which you then can use to deconstruct the data. But if you already know that there's some substructure in the file that we're interested in, and we don't want to get the whole file, and also want to stream the data, which is also important at these sizes, then we can use JSON parse here. So it's also in the documentation of APOCLO-JSON. So if you're interested in that, you can just basically Google APOCLO-JSON and then look at the docs. And in the docs, the JSON path is also explained which operators it has, and so on, right? What we do here is we do the dot name, and this would give me like the nodes in our case, right? So if you want to see this, pretty easy to find as such. So what we do, we grab the nodes here, and it basically would return one row per entry as such, right? So we can yield the value here and then basically return NV limit 10. So we get the 10 first entry, so it fetches the file from the CDN. And then for each entry, you see it has the key. And then within the attributes, it has, so the first one doesn't have a label for whatever reason, but the other ones have the label, so that's username. And then community, XY coordinates, color, and area, and so on, right? So this is all pre-computed already. That's basically the community detection and layouting all pre-computed. But I think we can use this and do this ourselves with Bloom and GDS as well. So we can basically compare and contrast a little bit the pre-computed values from the ones that we will compute as such. So we can also do things like PageRank and so on. Okay, if you want to import this data now into Neo4j, we would turn each of those entries into a node. So I'm using epoch periodic iterate here because that helps me with batching the imports as such, because that works quite well. I think you can also use colon transactions, but last time I tested it, it had an issue. It should probably not have an issue on this DS instance because it's large enough. But last time I tested it, I ran into an issue. So that's why I used epoch periodic iterate to run on all 4.x and 5.x Neo4j versions. But we can actually try to use it in, try to see if we can actually make it work with colon transactions, which would look like this. So we do our epoch.json, our value here, and here we would say call with NV, and then do our merge here, and on create set to this. And so what it does is basically for each row or each batch of rows, because we say here in transactions of 10,000 rows, right? So for each entry here, it would create the user node and then set all the attributes except for the key attribute onto this node, right? So it adds all the additional attributes from the attributes field here, except for the key, which we'll remove with the epoch function here. And so last time I tried it, it didn't work. Let's see if it works today. So this would be like the proper 5.x Neo4j version of it. Let's see if this likes us. Oh no, we have some duplicate entry for a user. Okay. So either we can just turn the constraint. Let's drop the constraint user label for now. Try this again, and then we can probably merge the user nodes on the label. So, which I would have not expected that they have the same label. So let's see. We want to see our users, and user dot label the number and collect you as users. Count this label. So we basically just aggregate our users on a label, and we want to see where the count is greater than 1, right? So where we have duplicates, and let's see how many duplicates we have. As such, we have only 1 duplicate, right? And so we have this Lewis person who has 2 entries. You can actually see what kind of interact. Oh, it doesn't have any interactions yet. So this key is 13458, and this one is, where's the key? It doesn't have a key. Oh no, 32. So we could merge this one, or we can drop one of them if we wanted to, right? Good question. I would say let's leave the data for now, and then let's merge them when we added the relationships, so we can basically keep the relationships and merge them together into one user node, and then we create a constraint again for the label as such. Okay, super. So if you have questions, just share them in the chat as such. So we have only one duplicate user, which is actually interesting. So we said that this is Bluesky, right? So if you copy this one here, copy, and we go back to our atlas here and look for the handle, this person. It probably errors out because you have two entries or something like that. Oh, does it? I think it, perhaps it's also a test user. I'm not really sure. We need to ask. It had only interacted with the with one of the developers of Bluesky, and so perhaps it's also a test user. Okay. Okay, so we imported the nodes into the database, and if you refresh our data here, so we have roughly 20,000 nodes in here. So we can visualize them, but it doesn't really show us so much because it's all lonely nodes, right? So they are not basically connected yet, right? So, but we want to, of course, have the connections in the data. So next, we're going to import the relationships, which are also in the same file. So we can actually, let's see here. We can take the relationships and we do the same. So I can rewrite my statement here from the epoch one, which might be more confusing to you, to call in transactions. So we call with EV this time, which means edge value, basically. So we match the source user and the target user from the source and target field. Actually, can probably initially return EV limit 10 so that you see what it looks like. We have a source field, we have a target field, we have also a key for the relationship as well. And then we have size and weight attributes. Yeah, right? Okay. So what we can do here is, I'm not sure if the key is really needed for this interacted relationship, because there should be only one interacted relationship between two users, right? So if we remove the key here, it will be much faster. Perhaps we can do this actually. Oh, let's keep it so we have the exact data as the original. So we have the source, the target. We merge on the interacted relationship and this key, and then we set the other attributes on the relationship. Right? So we find the first node, source node, the target node, and then we merge. So merge means get or create. So that means if the data already exists in the graph, it's just returned. If the data does not exist, it's created exactly in the same way as we spelled it out here, right? So for instance, if there's already another interacted relationship with a different key, it would create a new one. And if there's exactly the same relationship with the same key between these two nodes, then it would just return it as such. Okay. And then we set the attributes from the event. So the size, weight, and OG weight here. Right. So, and then in transactions of, let's say, 20,000 rows. Right? So it will do a bunch of batches, and then after a few seconds, it should be done. Let's see. Okay. So it created 142,000 relationships with 568,000 properties. So we can now actually look at some of those, right? So we can here just click on the interacted relationship, and if we increase the limit, let's say to 100 or so, then we would see a bit of clusters here. So one node has a lot of relationships here in this one, so lots of interactions. A few nodes have a few relationships as such, but of course you want to see a little bit more data than this, right? So remember, the query tab is more from a developer perspective, like interacting with the database with statements, but it's not meant for large scale visualizations and things like that, right? So this is where basically Explore comes in. And what we can do in Explore is we'll just recreate a new perspective. Let's see, delete and generate perspective, which is basically an UI visualization view of this. So we can also rename this into Bluesky. Bluesky. Okay. And now this has our user node and our relationships here, right? And what we want to, or what we can do, I don't want to use the other attributes yet. We can look at them later, but I just want to use the user label right now as a text. We could also do an icon if we wanted to for user or something like that, right? So then it would show us users. So we can basically get users by themselves, which is kind of semi-useful, right? So because that's just basically lots of disconnected nodes. But we can also get user-to-user interactions, which you can also do by just selecting all these nodes that we have here, all 10,000 nodes. So you can just click on this here on the right side that they are all selected. And then we just say expand all. And this fetches another 4,000 nodes. So it becomes a little bit more interesting here, right? So we can basically do this a few times. Expand all. So I want to fetch just a few thousand, let's say 10,000 users or something like that, right? Let's see if this works. Okay. We select them all again. And or can we actually select the offense? Why can't we select all? Oops. Oh, it's currently loading. There we are. So it has 44,000 users, 3,000 users and 41,000 relationships here, right? So we can actually, let's hide this for a second. So this is something that we can look at when we look at an individual node, then we also see their attributes. We can edit a node or relationship as well, right? So if I look at a node, then I can also edit the relationships and the attributes as well. And why doesn't it collapse here? Oh, okay. I think the icon is wrong, right? So it should be collapsing. Anyway, so we have now 3,000 nodes. Let's do this once more so that we have a little bit more data here in the scene. So in general, you can set a node limit here, but in Workspace, that's not available yet. So from that perspective, we just need to use this trick of exploring more or getting more data in. Actually, we can also do something else, which is basically saying, can we get an user-to-user graph as well? Let's see if this gives us a few more nodes. So we have 4,000 nodes and 66,000 relationships now, right? So you see it's pretty dense in terms of relationships here, right? So there's a lot of relationships here. So, okay, what we can do now is you can run a bunch of graph algorithms on this, right? So you see this chemical or whatever you want to call this chemical sign, and we can run algorithms on this. So graph algorithms are actually ways of taking your graph data and and running unsupervised machine learning on it. So for instance, a common algorithm is PageRank. So what is the most important node in a certain cluster? Or another algorithm is clustering algorithms like Louvain or weakly connected component that says which nodes are more connected with each other than with the rest of the network, right? So you basically can run these algorithms on your graph data, and then you see basically patterns emerge, right? So who's central, who's connected, and so on. So what I can do here is I can, for instance, pick the Louvain centrality algorithm on this data. I can also basically select what I want. I can pick relationship weight, I think, as an attribute, and say that these are undirected, and then I run the algorithm. It should just take a few seconds, and then it runs the algorithm, and then it can actually color the data based on the algorithms, right? And you see already here that these groups of nodes that we as humans see visually clustered together by the layout algorithm. Imagine there was no layout algorithm. Imagine this was all just, node data as such. Those are forming clusters here now, and you see the red cluster, the blue cluster, the yellow one, the brownish one down here, and the green one up here, right? So if you, for instance, pick one of these clusters here, like the one on top here, the green one, then we could, for instance, see did our Louvain algorithm kind of come to the same conclusions as the algorithm from Jazz. So for instance, if you look at, so this is community 11. This one says also community 11. This one says also community 11. So you see our Louvain algorithm came to the same conclusions as Jazz's algorithm, which is good, right? So, and then the other thing that we can do in terms of graph algorithms, we can also run a another algorithm, something like PageRank, for instance. So what nodes are really important in this network, so which have a high transitive importance, right? So not just direct, how many neighbors does a node have, but also how many interactions does a node have directly and indirectly. So the more people I interacted with that have also a lot of interactions, the more I benefit from that. So that's where the PageRank algorithm came from. And we again use the weight property on our relationships, and we picked the undirected one because we didn't import directions as such, because these interactions are bidirectional, right? And then we can apply the algorithm, and it takes again a few seconds to send the data to the graph data science library and run it. So the running actually takes just a few milliseconds. It's more like the data transfer back and forth. And then it should give us the results back, and we should be able to size the node differently as such, right? Let's see. Okay. So now we can basically do size scaling. And you see now, or should see now, that some nodes have become bigger than others. Here, for instance, here's one node, Bluesky is bigger than other nodes. What else do we have here in the middle and the yellow one? We also have some nodes that are bigger. You know what we can do? Actually, we can remove some of those many relationships. So what I can do here is I can apply a filter on relationship weight. Let's say weight. And let's remove the ones that have only like 2 interactions, right? So every one that has only 2 interactions is now grayed out. And if you say dismiss filtered elements, it should remove them from the screen. And let's see. Are they gone? No, I think it's still computing. And now, so from the 66,000 relationships, it should go down quite a bit. Let's see if it does. Okay, so it removed 15,000 relationships. And you also see now that the layout becomes a little bit more less dense. We have a little bit more orphan nodes. Actually, what we can also do, we can also dismiss single nodes, so it becomes like our central cluster is becomes more important. And then perhaps we can actually increase this to have at least 4. So let's see what happens there if we separate clusters or not. So 4 interactions, that means 4 replies or responses between interactions between users, right? So you now see we got more single nodes and smaller clusters where people talk to each other, but our cluster also got a little bit less dense here. So I wanted to see this UI user, if this is also a larger user on here. So this one. So you see that this is also a user who has a lot of interactions, right? Which is interesting. So we can basically look at this user. If we look at their profile, so 22,000 posts, no followers. So this looks like no one following. So this looks like perhaps like a bot or so. Yeah, looks like an social card bot, Japanese. So my Japanese is really bad, so actually non-existent. So I would have to ask my wife if she could help me. But you see that someone who has a lot of interactions, lots of posts, and lots of followers as well, and that's where the size comes from, right? So, and that's in the Japanese cluster. So that means in the atlas here, so you see it's also in the Japanese language cluster, right? So there's a lot of other people that kind of reply to it or interacted with this node as well. So it's also bigger in our original data from Jazz, right? So, and we can also, if you want to, in terms of like styling and so on, we can also use Jazz's data directly for the styling. So imagine we wouldn't want to use our graph algorithms, or we didn't have the GDS library because Jazz has already pre-computed these kind of things. We can also just say we want to add another rule-based styling. For instance, we want to look at something like community here and say this is an unique values and apply color. And so it will probably read color everything. Let's see. I'm actually not sure what happens if they both go on color. Actually, it might be that we need to remove the Louvain one, the PageRank one. So these are now the colors that are coming from this community field. It would be nice if I could just disable these rule-based styling. So I'll let the team know. Actually, I could have probably done it by disabling this in Louvain and PageRank. Anyway, and then we can do the same for size of the node here. And we say this is a range. And we want to apply it to size. And then refresh the range. So it goes from 1.5 to 13. And the smallest one should be really small. And the largest one should be really big. And then we just apply it to size. And then you see now the data from the original data actually being applied. But you see that it's basically the same clusters and communities here as well as we had before, right? So that's rule-based styling for nodes, but we can also do rule-based styling for relationships. For instance, we can say we want to have the size of the relationship or the weight. I think we used weight, right? And it has a range between 4 and 2,000. And we want to actually apply this as well. So the really small ones, because we removed 2 and 3, right? The really small ones get really small and the really large ones get really big. And if you apply size, then you see also that the relationships become much more transparent. Many of the relationships become much more transparent because they're much smaller. And then there are a few big ones as well, right? Cool. And the last thing that I want to show you here in Bloom is because Jazz did a pre-layout, we can also switch from force-based layout to a coordinate-based layout, and then basically use either point coordinates for map-based data, like latitude and longitude, or the point type in Neo4j, or like here, X and Y is already from Jazz's data, And so we can basically say, I want to use his layouts, and I can basically play around with the scales here a little bit, just in case the scales are not really right. But in our case, I think it should be fine. And so you can also pre-compute layouts and keep them as such. Actually, it would be also a nice feature for Bloom is if the pre-computed force layout could be actually kept and stored. So especially imagine if you dragged and organized stuff in a certain way and you want to persist that, then that would be really nice if it could be actually stored in a graph. So the next time you load it, it looks the same. Probably another feature request we can send to our Bloom team as such. Cool, that's what I wanted to show you here. And the last thing is something that just released 3 days ago or something like that, which is so you have really nice posts like Neil Gaiman talking about looking like his father here and other things. I really like these paintings as well. And here's like Jess posting always updates about his latest developments. So he actually, when we looked at the code on Thursday, it's really impressive code with proper, error handling, operations, operability. It's a Docker Compose container. It has a lot of proper Go coroutines. So coroutines and channels that interacts for multi-threading and so on. It's pretty nice done. And we wanted to see if we can add Neo4j support to it as well. It would be a fun extension, right? So if you look at what Jess posted here, is that he basically said that he provided a branch or a thread view, right? So there's, as like in many social media platforms, there are threads. And so someone posts something, other people reply to that, and that forms a tree, basically, right? So basically, if people would only reply to the original poster in a straight line, that would be like a single threaded thread. But because people kind of cross-reply from the sides, you kind of have this branching out structure, which then forms a tree as such, which is actually interesting. We should look at this into Bloom as well. So, and he built this thread view, which allows you then to look at different threads. And there are a number of threads which actually were so big that they broke the iOS app. And you got this really beautiful, nice red error message. And one of these threads is called the health thread because it's so big. And this is, I think, this one. Is this one or this one? This is the health thread. So it has 7,800 posts now in the thread. It might be even 8,000 already. Let's see. Yeah. And 500 users are engaging here, right? So this thread starts somewhere there, and then it basically goes all the way off to other places, right? And you see, as a graph visualization, it looks quite interesting. And what's nice is he has also, this is also available as a JSON. And in the JSON this time are not users and their interactions as such, the aggregated interactions, but instead they are the original posts, right? So you see we have a post file, as a post entry with an ID, text of the post, parent post ID, which is kind of creates our relationship, the root post ID, which basically ties it back to the thread, which we probably don't want to import, or we just will import as an attribute. The author, which is also linked here via the handle, and then created at, and then has embedded media or parent relationship, right? And then it has XY coordinates as well. So I thought something that we can do today here on the stream, which I have not done before, is actually importing this thread view, and this should be about 8,000 results. So let's see. So we if we call epoch load JSON on this, and if we just want to get the array yield value as post, return count star, and I hope I didn't mess up the syntax. Okay, we need to look up the JSON path again. JSON. The syntax for extracting the array. JSON path here. So we want to get the root element but if we don't have a root, let's see. Okay, this gives us 5,400 entries, so this looks actually okay, right? So you can also look at the return post limit 5. And this gives us 1 entry for each post, right? So we have the X and Y coordinates, we have the author handle here, right? Which reminds me, we wanted to merge this one node that had duplicate entries, right? So let's find this again from our history. This is actually a new feature that one of my colleagues showed me recently. If you press Control R, then you get history search. And we should be able to see our count greater than 1, this query. So we can just run this, and we wanted to merge these nodes, right? So what we can do here is we can do call epoch factor merge nodes, pass in the nodes here, and then there are some config options which I don't think we need to use, so it will just merge the nodes in the relationships as well. So yield node return node. It has only now 1 node, and it has like all the relationships basically from this 1 node. Right? So we don't have any duplicates anymore, right? So that means also that we can now create our constraint to label. Okay. So that means now we can quickly look up nodes by label, and we also are guaranteed that they are unique. So we need this for actually the author interaction here, right? So what we can do now, we load these posts, and we find the user who posted it, and then connect to them, right? What we can also set, the DID of the user on the user itself, so we don't need to have it on the post. And parent relationship, I think. Let's see, parent relationship is always null here. Let me see if I find one where parent relationship where post.parent relationship is not null. See if we find any. No. Okay, parent relationship always seems to be null. Interesting. So let's just keep this here, and we do the same as we've done before. We do our load JSON. We do our call in transactions. Actually, it's not so much data. We can also save this and do it directly. Or let's do it properly. Then I can use it in the call with post in transactions of 10,000 nodes rows. And then what we do here is we create a new post ID, which is this here, right? So we say we create a post. The ID is post.id. Oh, sorry. It's post parent relationship. So let me try this again. It's post.post. Should probably call this entry, and then entry.post. Good for paying attention. Hey, Ashwa, good to see you again. Let's see. Entry with entry.post.id. That's our post. else that I forgot to do is we of course also want to create a constraint on post ID on post where p dot ID is unique. Right. So we have 10 minutes to go. Let's go for it. So we have our post that we created here. We say on create set p plus equals. What do we want to do? We want to use the entry field, the x, y, and the author handle we don't need because we will find our user on the author handle. Label is entry.author. And then we create a user posted p relationship here, right? And we also want to set p equals. What do we want to set? With entry and entry.post as post. Save this. And then we just set post dot. So we want to set the root post ID as an attribute. Parent relationships always seems to be null. The author DID we can actually set on the author. Set u dot DID is post dot author DID because we hadn't gotten that from the other import yet, so that might be useful. And then we say we got a root post ID. The has embedded media. We want to set created at, and we can actually turn this into a datetime, so which is a date time of post dot created at proper datetime attribute and the text, of course, right? Text. So we have two attribute sets that we set. One is the kind of XY coordinates and depth, which is kind of the visual attributes, which you could also just ignore as such, right? But I just wanted to save it. And then we said the root post ID has embedded media, created at, and text. And was there else? Something else has embedded media. I think that's it, right? And this should take all our posts and turn them into a graph, from this thread, turn them into a graph, right? So let's see what happens if you spot any mistakes. So we need to have a star in between here. Sometimes we need to put in things like that. And now it does the load JSON and created 5,400 nodes. That means if we now look at our data here, it should have a new post entry. And if you look at the posted relationships, then this created them. And I just realized that I forgot something, which is the parent relationship. Okay, because let's look here. Our parent post ID, that's what we wanted to use to actually connect to the parent post, right? So I forgot about this, and but because we used merge here, this all should be idempotent, so we can just rerun it, and we just do a merge on parent is also a post, where the ID is post.parent post ID, right? So that means if the post has not yet been created, it will still create a placeholder. We then also not just use on create set here, but just set. It will just create a placeholder, and then later on it can fill in the data here, right? And then we merge from our post with a parent relationship to parent as well, right? Okay, and we do have to have another with in between them, so we can also probably just move this up here. Let's see. Okay. I don't really know why we still require this with star in between here. I think that's some over. So there's one extra node that got created, one post node, and it created now all the relationships. That means if we now look at our parent relationship, so this should give us the thread view here, right? So this is our root. You see that's kind of the idea, 3j. That's the same as the root, right? We can actually find the root as well. We can say match p post where p.id equals p.parent. Sorry, root post id, return p, 10. Let's see. Why didn't it find anything? Because it should have been this one, right? Oh no, 2.6 and 2.4. Interesting. But we can also find the root by saying where not exists p parent. So that's the post without a parent, right? And this is this one, 2.2g. And then from here we have like one that goes out and another one and so on, right? So, and what's now interesting is from here, from this root node, we can actually say we find all, let's say 5-step paths or something like that. Path equals here parent post or whatever, and then we just say everything that is, let's say 5 steps away from this, right? And then instead of returning the post, we return path limit 50 or something like that, right? So, and if we do this, then we find our paths here. It's actually not so many. Oh, that's exactly 5 hops away. That's okay. Then let's go with 10. So this is 10 hops away. If you go 20 hops away, this gives us something like this thread view. And so this is basically, and this is if you go 50 hops away, this is kind of these, right? So you can see these variable length things here. Okay, if you go back to explore, we can actually add, we can refresh this and add our posts. There it is, our post as a category. And it also determines that this is a daytime property. So you can also see how posts are changed over time. But what I wanted to show you here, let's just take a screenshot because I really like this view. Before we get rid of this one, so let me clear the scene here. And why is this taking so long? Okay. So what we can do now is basically we can say we want to have a parent post relationship here, right? And if we fetch this, hopefully it gives us a nice tree view of our data. So it found 1000 nodes, right? And you see like all these nodes already. So this is kind of the normal graph visualization, the force layout graph visualization. So what, oh no, coordinate layout. Sorry, this is kind of the force layout. So it's basically one big ball, right? But what we can also do is we can look at the hierarchy layout, right? So which basically starts at our root node somewhere. It should be this one. And then from here, as you remember, there was like one node going off this, and then like the other ones, and then it pans out basically, right? So which is really nice visualization of the root. And I think with the root layout, with the hierarchical layout, you can flip it around, and then the root is on top. And then basically we can look at things like that, right? So we can also look at like different colors based on the depth or something like that, right? So I could also say I want to do a rule-based layout here of depth, and I want to say this is unique values. I apply a color, and then I see one per color. I can also say this should be a range, and then I just do an they go darker the deeper they are, or I can go on size or something like that, right? So that's also possible. And so I can also represent how deep a post is in this hierarchy. So, and if you import a bunch of these threads, then we can, we can actually pick any thread here. So, for instance, if we pick, let's say, if you look at what's hot or so, probably not like what's hot, but if you look at this one has 62, right? So we can look at the thread ID here, or the post ID, and we can import this one as well into Neo4j by just applying this to our URL. And oh, there's no thread for this. Oh no, he pre-computed the threads, so they are not dynamic. He pre-computed a number of threads. I think that's kind of the difference. Yeah, so let's see how this continues, but I think there's a lot of good stuff coming here, right? So there's also other things where we can look at other threads and so on, right? So there's the other thing that I wanted to show you real quick is, where do we have Neo4j here? If you look at our threads here in whatever layout we want, we can also go back to the four-space layout, but it's not so nice. Let's stick with we can also go to the coordinate layout, which is basically what we had. You can also expand, expand a bit more. Parent and expand. Parent. Actually, what we can do is two things. We can create a cipher statement that finds us our switch graph. Let's say thread, and we just say match p post with, let's say, parent 100 or something to 100, path, and then return path. And then this is our saved cipher query now. And now we can basically use here thread. And if I press enter, it should give us some more data, hopefully. Let's see. And it's only for 5,000 nodes or so, right? So for Bloom, this should be possible to fetch. And then we can visualize this. So what I wanted to show you actually while it's loading is this slicer here, where we can basically say we want to look at the created at. Why is this hanging? Come on. I think it's still hanging with the loading. Wait. Come on, it's not so much data. Can do it. I know it. So we also see that it's actually not really busy, the database, right? So the database is actually like a little bit bored. So it's probably more the data transfer and handling in JavaScript in the browser as such. Come on. Then Ashwa asked if you have no users, how can we display user-wise? So if you have no users, then you can't display them. If you have only posts or so, then you would only display posts. But you can also show the users that have posted something, right? And actually, what's interesting is if I open Workspace here again real quick, while the other instance is loading, I want to show you that you then can actually take the data from the posts. So remember, we have this posted relationship, right? A user posted a post, right? And the post, the user, so we can actually do user interactions via posts, right? So we can basically say who posted to whom. So for instance, we can say, okay, a user posted a post, right? User one posted a post, and this post has a parent, so it's kind of a reply, right? And this parent was also posted by a user, right? So we have two users, one post. This has a parent post, and this parent post was also posted by a user, right? And what we can do now is basically we can visualize them, of course. So that's kind of these pairs of, or these triples basically of users posting and their parents. But what we can also say is we can say return user, or let's aggregate first with user 1 and user 2. And count how often did they basically interact, right? And then as count, order by count descending limit 50, return user 1.label, user 2.label, and count. So we see actually how many people basically collaborated with each other or interacted with each other, right? So you see basically the same people. We probably want to say where ID user 1 less than ID of user 2. So we basically filter out these duplicates. So we also filtered out now people responding to it themselves. But you see that a number of people had quite a lot of interactions here in this thread, right? That we imported. So you can use this to create a user-to-user interaction graph, and that's actually what Jazz has done with the first visualization that we looked at, is basically the user-to-user interaction graph. So these number of interactions here that we have from the single thread, if you do this on the whole data set, then you get basically the interaction graph between users. You could also say, I want to see only distinct interactions or something like that. So not within the same thread or something like that, right? So that you say, okay, how many independent conversations did people have with each other as well? But that's something that you can then here see as well, right? Cool. Did it finish now? Did it load all the data? Yes, I think so, right? So this is still coordinate layout. We can look at hierarchy layout, which is now much deeper than original, right? And now what I wanted to show you really quick before we leave is in this slicer here, we can look at created at, but they're all on the same day. So it's a little bit sad. Oh, that's only date, right? So it's not time information. But in general, what you can do is kind of, you can replay this, right? So if your data is created over time, then you can basically replay how data is being added to the graph, right? Or you can also do expansion, start, so that it basically starts at 0, basically, or something like that. And then you see how data should be added top to bottom, right? So this is on this day, and then on the third day, this other data got added as well, right? So unfortunately, this doesn't do date time yet. So that would be nice to have date time support. So that's another thing that I can ask my colleagues to consider as a feature request. Yeah, otherwise you could also slice it by other information, right? So if you want to say you want to slice it by depth or something like that, then it's also something that you can do. Right? So you can basically say, this is my depth range, and starting from 0, basically, I can expand how this grows. Oh, sorry, how this grows over time. Right. So you see, it basically adds each level over time. Right, and in the other layouts, let's say if I stop this, if I pick another layout, why can't I change the layout here? Let's see, we change it to the coordinate layout, for instance, or the 4-space layout. So this is kind of like a little bit of a mess, right? But if you now add the slicer for depth here, then you can start here at day 1 and expand as we grow to the end. So you see it adds more and more levels of the thread, and you also see things appearing in block when like a whole new level of the thread appears, right? So this one is a new section there. Right, and should probably stop at the end as well and not jump back. That would be nice as well. Cool. That's so Ashwa also asked. He asked about the number of users. So I'm not really sure what you mean with the number of users. So in terms of like how many users you can put into the database, it's kind of not limited. And in the UI, so Bloom can deal with 10,000 nodes as such pretty directly. Cool. Thanks, you liked it, John. I think that's it for today. I'll try to summarize this into a blog post. I hope I find the time today to do that. And otherwise, have a great afternoon or rest of your day. And see you again next week for the next session. Take care, everyone. Bye-bye. Oh, no, I forgot something. Don't forget about notes. So we have, if you go to neo4j.com/notes 2023, I almost forgot notes. How could that be? You can either sign up to notes to not forget the date, or even better, you could submit a talk. So if you're into it, please feel free to also paste it into the chat. Feel free to submit a talk as well. Call for papers is open until end of June, but the earlier you get, the better, because then you can get into the early selection of speakers. So 24 hours again in October will be awesome, and I can't wait. So please don't forget to sign up to notes as well. Cool. Thank you all. Talk soon. Bye-bye.